Okay, the next one, 8.4. Uses of radioactive radiation. Radioactive radiation in daily life. Radioactive radiation such as alpha, beta, and gamma are used in various fields in daily life as follows. So we want to know what are the use? Is it important in our life? How we are going to uh, utilize it for our benefit? So the first one is archaeology and geochronology. So sometimes some of you may think how people estimate the age of fossil or dinosaur bones. How do we know how long it existed and how long? Not only for dinosaur bones, can be anything which is we existed long time ago, and how we estimate uh, the the time when it existed. Archaeology and chronology. Geochronology. Carbon dioxide in the air is made up of carbon 12, C12, which is stable, and carbon 14, C14, which is radioactive. So we have two types of carbon, carbon 12 and carbon 14. As carbon dioxide is absorbed and released by the body of living organism, the percentage of C14 in the tissues of organisms doesn't change. Okay. So C14 uh, doesn't change. Okay, the percentage of C14 in the tissues of organism doesn't change. As soon as the organisms die, the amount of C14 in their tissue begins to decline. Okay, so we will be able to estimate from here because we know when it starts to die, when it dies, then the amount of C14 will decline or will reduce because they decay by emitting beta radiation with a half-life T half of 5700 years. Okay, we have learned about T half-life, right? Half-lifetime, we have learned that. So half-lifetime for carbon 14 is 5700 years. By measuring the activity of C14, the age of the remains can be determined. This method is known as carbon 14 dating, and is used by archaeologists or geochronologists to determine the age of fossil and artifact. You get that idea? I think we have learned this before. Okay, so we have learned about the graph, remember? You still remember this graph? Okay, half-life graph. Do you still remember? Like this. So this is the time when uh, the cell die, and then the amount of carbon 14 will decrease slowly, like this. You can see the curve here. So you will be able to know that half. Okay, for example, this is M. We don't know. I mean here the activity. Maybe I can put another symbol. For example, uh, A. Just use number A. So half A or A over 2. This is, you can see here, this is 4700 years. 4700 years. This is time, this is years. So we measure how much is the carbon 14 activity. Okay, then we'll be able to know how long that fossil is. Okay, based on this graph. Okay, I think we have done exercise about this. You should understand it by now. And then the next one is monitoring the thickness of metal sheets. A thickness control device monitors the thickness of metal sheets in factory as metal sheet is passed in between beta radiation source and a beta radiation detector. If the beta radiation detectors detects too much beta radiation, this means that the metal sheet is too thin. Okay, this is how it works. Let's say, okay, let's look at this. In this case, they are going to measure the thickness of this metal layer, okay, metal sheets. Okay, so let's say that this is radioactive sources and here is the detector at the bottom. So when the metal sheet moves, right, it keeps moving, and then the radioactive source uh, will produce radioactive radiation, and then the detector at the bottom will detect the amount of radiation. If the sheet or the metal sheet is too thick, then there will be less amount of radiation at the bottom. So the detector can detect less radiation. So this means that this metal sheet is thick. But if it is thin, so there will be more radiation that can pass through. So the detector will detect more radiation. So from here, we will be able to determine whether this metal sheet is thick or thin. If it is too thick, maybe they can take further action. Maybe they can reduce the thickness because usually the metal sheet is meant to be thin, usually. Okay, actually, it depends on how much they want it to be, thinner or thicker, it depends. So this is the method how we determine whether it is thick or not. Understand or not? And the next one is agriculture. In agriculture, the rate of which beta radiation is emitted during the nucleic decay of phosphorus 32, P32, is used to determine the absorption rate of phosphate fertilizer in plants. Radioactive radiation is also used to kill beetles, control the population of pests by sterilization, determine the best type of phosphate fertilizer, and modify the characteristics of the plant. So when we apply fertilizer on the ground, and then it will be absorbed by the tree, right? And then we use this detector to detect how much the absorption of the fertilizer by the tree. So this is how we use it in agriculture. Next one is defense, nuclear bomb. Okay, nuclear bomb. Okay, however, Malaysia signed the ICAN agreement to ban nuclear weapon because nuclear weapon is very dangerous. Because we have learned that Japan went through very horrible time long time ago in the past because there was an atomic bomb dropped by American soldier, right? So we need to ban this nuclear weapon because it's so disastrous and horrible. The next one is food preservation. The Radura logo in Figure 8.1 used to label food preserved using the radioactive radiation such as gamma ray. Gamma ray are used in preservation food such as fruit to kill the bacteria because gamma ray can kill bacteria. So this is one application in order to get rid of bacteria. So this fruit is safe for us to eat. And next one is in medical. Gamma rays from cesium-137, CS137, or cobalt-60 are used to kill cancer. Okay, this is one application to kill cancer cell. But the doctor must be able to identify the location of cancer in the patient's body, and then this radiation will be directed towards the cancer cell so that the cancer cell will die. This is one type of medication used to kill the cancer cell. Radioactive radiation is also used to determine the location of blood clots using sodium 24. You know what is blood clots? Blood clots. Okay. Uh, the next one is treat tumor in the brain, destroy germs, and treat thyroid glands. Okay, now the next thing is how do we handle radioactive waste? Okay. Storing radioactive sources of radioactive waste in containers with thick lead walls. Okay, remember this container is made of lead walls because we know that lead can stop gamma ray, and of course lead can stop alpha and beta radiation also. So we use lead. Radioactive substances are shielded with thick slabs of lead. One more time, we use lead to avoid leak of radiation. Robotic hands are used to handle radioactive substances safely. So we use robotic hands. We don't use our bare hand to handle radioactive substances. Detecting the dose rate of radioactive radiation absorbed by the body with detectors such as radiation badges. Maybe the staff or the crew that are working in the factory or any power plant, nuclear power plant especially, they need to use this badge because when uh, that person is exposed to radiation, the color of this badge will change. Okay, because we cannot see the radiation, so we use this badge to detect whether we have been exposed to the radiation. The color of the badge will change depending on how much you are exposed. Disposal of radioactive waste done safely and properly. Usually, radioactive waste is buried underground, okay, or sent far away from human. Wearing appropriate protective clothing when handling radioactive substances. So they need to wear proper clothes to avoid radiation. Okay, that are among the measures taken. And appreciating the importance of radioactive radiation, you can pause the video and watch it and read it yourself. Okay. So that's all for this topic. Do you have any question about this? Do you have any question?
No, sir.